All right, cool. Welcome, guys. My name is Lalitha Fernando. I'm a program manager on the OS Fundamentals group, where I work on the Windows Performance Toolkit. Now, the Windows Performance Toolkit, if you guys aren't already familiar with it, is a very powerful set of tools that really enable you to investigate and understand performance issues in your apps. And that's what we're going to be talking about today. We're going to be spending most of our time in demos looking at how you can analyze performance issues in your apps, whether they be on Windows or Windows Phone. And the reason we're really passionate about making this easy for you as possible is that we all want there to be great apps in our stores that our customers love and that our customers want to come back to. Now, we care about this because our customers are the ones who are judging the performance of our apps. Performance is a UX issue. They're the ones who decide how fast it is, how responsive it is, how fun these apps are to use. And we want to make sure that, hey, if they have 2 minutes waiting in line to spare, what app are they going to launch? Are they going to launch the one that takes 5 seconds to start up before they can even start playing with it, or the one that starts up almost instantly? So we want to make sure that you guys have the tools that you need to make your apps have the best experiences possible. Now, speaking of these tools, there are a couple of ones we're going to touch on today. Visual Studio. You guys already use it to write your code, I assume. It also has some powerful analysis capabilities. And if you were at some of the other talks, you saw that in action. Now, I'm not going to touch on that today, but if you're interested in that, I'll link you to those sessions so that you can check those out. The Windows Phone SDK for 8.1. That gives you the Visual Studio Developer Power Tools. I'll show you how to use those Developer Power Tools to capture traces on Windows Phone. Now, once you've captured traces, you're going to be analyzing them using the Windows Performance Analyzer, which comes with the Windows Performance Toolkit. Now, this toolkit allows you to capture traces on Windows, but where we're really going to be spending the majority of our time is in how you can use the Windows Performance Analyzer to dig into your traces, to your performance issues, and figure out what's going on. Now, I have this download link here that links you to the RTM version of the tools that you can check out and download and play with. Now, once you have the tools, really the first step in getting started with performance analysis is identifying your scenarios. Now, you want to focus on scenarios that have high value to your end users, are key ways your app will be used, and currently have noticeable, painful performance problems. And the reason we want to do that is we want to spend our time where it counts, and we want to turn those experiences that make our customers want to leave and turn them into ones that make them want to stay, come back, leave ratings and good feedback that attract more and more people to our apps, so we have more and more people spending time in our apps. Now, once we've identified our scenarios, it can be helpful to break it down into one of two buckets, fast and fluid. You've probably heard those terms before. And we use that a lot. And it can be helpful to break it down into these two buckets because that helps us with two things. One, it helps us understand when we're successful in improving the scenario. For example, with fast, when you have scenarios like app launch or page navigation, knowing it's the fast scenario helps us understand, OK, we want to reduce the amount of time we spend in that scenario by 10 milliseconds or by half a second or whatever it is that you want to make better. The second way breaking it down into these two buckets helps is with the type of analysis we're going to do. For fast scenarios, the type of analysis we're going to do is we're concerned with going from point A to point B. We're concerned with going from the start of our scenario to the end of our scenario, from tapping on the live tile to a responsive, interactive app state. We want to make sure we get from A to B in the smallest amount of time possible. So our analysis approach when investigating these fast scenarios is going to be to dig into that time between that A and B and identify exactly what's happening, figure out why it's happening, and then see what we can do to reduce it, to eliminate it, to defer it, to do it faster, right? And so the scenario we're going to look at in demo in just a second is going to be a page navigation. So we'll look at that example in just a moment. Fluid is about 60 frames per second. It's about glitch-free experiences. It's about panning, making sure your content keeps up with your users' pans across the screen, right? And this, again, helps us define success in that, okay, are we at 60 frames per second? Is our content always on the screen? And then also helps us with our analysis approach, because here, what we need to remember is that we have a budget. We have a limited amount of time before we need to have our content ready so that it can be presented onto the screen. So again, we want to identify where we're failing to meet that goal and dig in and understand why that's happening and see what we can do to reduce the work required to get our content there. All right, now that we've identified and I'll look at a keeping up with panning scenario in the demo in just a moment. So now that we've identified our scenarios, the next step is take a trace and start investigating, right? And so that's what I'm going to do now. I'm going to spend the rest of the time in demos showing you how to take a trace on Windows and Windows Phone, showing you how to locate your scenarios within the trace, and investigating a fast scenario, page navigation, and investigating a fluid scenario, keeping up with panning. So all right, let's get to it. OK, so first, actually, how many of you guys, are you all planning on developing for both platforms at this point with universal apps? Yeah? OK, great. So well, some of you are tentative, but hopefully we'll win you over by the end of this session. So I'm going to show you how to capture traces on Windows Phone first. Okay. Now, I have Visual Studio here, and I've installed the Windows Phone 8.1 SDK. Now, what this allows me to do is go to Tools, Windows Phone 8.1. If you guys can see there, it gives me the Developer Power Tools. Now, when I click on that, I get this window right here, which allows me to connect to a device. And that's what I've done here. I've connected to this Windows Phone via USB. And actually, let me just go ahead and bring that up right here. And you can see that I have an app that I want to investigate. Now, if you were at Dan's presentation on Wednesday, you've seen this app before. This is the photo filter app that he used the Visual Studio tools to make better. We've identified another problem with it that we're going to investigate in just a moment. Now, to do that, I'm going to use the Developer Power Tools to capture a trace. So my first step is to connect to the device, right? Key point here. Please capture traces on physical hardware. Don't use the emulator, because that's not going to give you a representative example experience that your customers are going to get, right? So we want to capture traces with release builds on physical hardware and capture traces and investigate on the hardware your customers will be using, right? So I've connected to my device. And you can see I have 3 tabs here, but I'm really going to focus on the Performance Recorder tab. Now here, I can start tracing. But before I do that, I want to specify what information I want to capture. Now this is all ETW instrumentation, and I won't get super deep into that. But all you need to know is that you have a couple of boxes you can check here. You can see that I've already checked the XAML App Analysis recording profile. What this allows me to do is capture all the information that's pertinent to investigate and analyze a XAML app. Now, if I were developing on HTML, I would go ahead and check the respective box for HTML application analysis. And then I'm set. I can start tracing. Quick side note, you can note the XAML activity and HTML activity recording profiles. Those are just subsets of the app analysis recording profiles. So we recommend you typically just go ahead and use the app analysis recording profiles to do your work. So now I've connected to my device. I've specified my recording profile. Now I want to capture traces. So I'm going to go ahead and hit Start and then run through my scenario. And I'm just panning. And you can already see I'm not keeping up with my panning, and the content isn't rendering. And that's it. I just start tracing. I run through a very small section or a very specific experience, just a scenario I've identified. Now, you want to do this for 2 reasons. One, you know that everything in your trace is what's relevant to the scenario you're investigating. It makes it a little bit easier. But two, you're capturing these traces onto memory. And so if you take a very long trace, depending on how much memory you have available, you might be dropping some events at the front of your trace because it's a circular buffer. So taking a short trace ensures that you don't lose any critical events. Now don't worry, you can take a longer trace than this, but just be careful. If you note that some graphs aren't lighting up, that might be the cause, that you took a very long trace and you had very limited memory. So once I've taken that trace, I can just go ahead and save it. And I can just give it whatever name and save it onto my machine that's running Visual Studio. And now I've captured a trace on Windows Phone. Now let's look at how to do that on Windows. Now for Windows, I'm again capturing a trace on hardware I want to target. I have a Surface RT here, and I can use the Windows Performance Toolkit to capture a trace. So here I have the Windows Performance Recorder running. Now, normally the Windows Performance Toolkit is targeting x86 and x64. However, when you install it from the Windows SDK, for example, you also get redistributables that you can copy over to ARM. So that's what I've done here. This is a Surface RT tablet. I've copied over WPR onto this box in order to investigate this perf issue I'm having. And so I can see here, or hopefully you guys can see, I've checked. It's a very similar experience to what we just saw in the Dev Power Tools. And I've checked the HTML application analysis recording profile because I want to record an HTML app. And so I already have this app running. I've already launched it. And so I'm going to go ahead and capture a trace by hitting Start, navigating to my app. And I have a couple of pages with the different issues. And if you were at last year's talks, you might have seen this demo app before. And you can see when I navigate to this page, it took a moment before the processing was done and the page navigation completed. So that's the issue that I'm going to focus on in a moment. But I can just go ahead and run through the different other pages here. I have a layout issue. I have another panning issue where I've loaded the page, and then when I pan, I can't keep up with the panning. And I'm done. I'm going to go ahead and hit Save. I can give some descriptive text if I want. I can give it a title. Go ahead and hit Save, and I'm set. Cool. Now, that's how you capture traces. Now, at this point, I'm going to move on to actually investigating these traces. But is everyone with me? Do you guys sort of know how to capture traces? You guys good? Cool. All right. So how many of you have used WPA before, seen the Windows Performance Toolkit? Wow. That makes me happy. I'm on the WPT team. That's way more hands than I expected. That's cool. I'm really happy. I'll give you a quick orientation to it. Now, I do want to call out one quick caveat. If you are investigating traces captured of apps running on phone, there are a couple of graphs that won't quite light up with the Windows Performance Toolkit and the Dev Power Tools. Now, we're working hard on making those updates and getting that out to you, so keep your eyes open to that. But I'm going to show you a slightly newer version of the tools so that you guys can see that with this converged platform, the analysis approaches that I'm going to show you are going to be completely valid, no matter if you're capturing traces on Windows or Windows Phone. So a quick orientation to WPA right here is I have the Graph Explorer here on the left. This is my left pane. And it contains different categories that give me insight into WPA, or into my trace, into my scenario. And if I expand them, I can see all sorts of graphs. So I can see generic events here. That contains all the events in my trace. So if you want to go event by event and look at what happened, check out that graph, and you can do all sorts of cool things. Or you can just go in computation. You can see the different CPU graphs, and I can drag one over. And when I drag one over, I'm dragging it into my analysis tab. And so my analysis tab is containing my different graphs. And I see that, whoops, there we go, zoomed in too soon. I can see that my graph contains about 3 components. I have my graph itself, which is graphing my CPU utilization for each process. I have my legend that shows me what that graph is showing. And I have a table that's aggregating all this cool information that I'm using to graph into these different rows. So I can expand each row and see the CPU utilization, see the stacks, and you can note that what I've aggregated is what I'm graphing. Each aggregation represents a series in the graph. Now I can keep dragging over graphs in order to create a view that I want to use to analyze things, but we don't have that much time. So I'm going to jump to a view that I've already put together. And so this is another powerful ability of WPA, is to apply a profile. So if I go to Profile right here and hit Apply, I can choose to either browse or browse the catalog. Now, once I browse, I'm browsing for a profile that's collecting together a bunch of graphs into different analysis tabs that is preset to jumpstart my analysis. Now, the catalog contains a bunch of profiles that we think will help you get started with your analysis. And for you app developers here today, I want to call your attention to the HTML Responsiveness Analysis WPA profile and the XAML Responsiveness Analysis WPA profile. And that ships with WPA. It's in the catalog. Use that. Now, for the demo today, I put in a slight variation of that same profile where I've created a new analysis tab that has dragged over different graphs from those other tabs into one, so just so that we can go through stuff for the demo. So my recommendation is start with the profiles in the catalog, modify them to suit your needs, and then reuse them. And this way, you'll save yourself a lot of time. And so actually, as this is getting started here, I'm looking at an HTML app first. Now, how many of you are developing with HTML and JavaScript? All right, a couple hands. Cool. So I'm assuming the rest of you are XAML? Yeah? OK, cool. Now, don't worry, XAML guys. I'm using an HTML trace now to investigate this fast issue with page navigation. But the concepts and graphs are completely valid for XAML as well. They're actually the same exact graphs. You're going to see a couple of different names. Like you'll see layout for HTML instead of measure for XAML. And I'll try and call those out when I get to them. But don't worry, we'll look at a XAML trace next, and you'll see that things are pretty much exactly the same. So let's get started looking at this trace. So my first step in investigating a trace is to figure out where in the trace I want to look. Now, I have a couple of different tools I can use to do that. So first is this window and focus graph. And it does exactly what it says. It shows me what are the different apps, different windows that were in focus at any given time during my trace. And I can see right here I have WPR. That's how I started the trace. This is the trace. This is equivalent to the trace I just took on the surface just now, a few minutes ago. So I see WPR. I see Explorer, which is how I switched over to that. I see a bit of a splash screen. And then I see my app. Cool. And then I can see that after that, I again use Explorer to switch. And then I go to WPR to save out my trace, right? So now I've selected this. And you can see that it's selecting this time range. And I can right-click and zoom. And this trims my data to exactly the stuff I care about. So all that WPR shelf stuff is out of my view, and I'm focusing just on my app right now. But I want to get a little bit deeper. I want to investigate just that issue with page navigation, where that page navigation was a little bit slow. And so I'm going to use a couple more graphs to get a little more specific of where in the trace I want to look. So now I have the touch events graph. So this is generic events, a graph I mentioned earlier. It's filtered down to just the events that indicate that I'm touching my screen. And so I can see here exactly, OK, I see the first app. That's when I navigated to that first page that had the issue. I see the second tab when I went to the layout page, the layout issue page. I see the third tab when I went to the panning issue page. And then I see the pan. I see a bunch of touch events indicating a pan. So I know that I probably want to zoom in somewhere like slightly about there. And I'm going to use the keyboard shortcut that time. I use Control period to zoom in to that time span. Now I've again trimmed my trace to focus on just the stuff I care about. Next, I have frame rate. So this is DWM frame rate. This is the desktop window manager. That's your compositor, which is what's putting your app's content together on the screen and posting those updates to the screen for you. And if you want more details on that, I'll I'll link you to another talk that goes a little bit more in depth. On phone, you're going to see mobile UI.exe instead of DWM. It's the same idea. It's another compositor. And I'll show that in a moment. But the idea is this graph is showing me when the screen was active. And it's showing me how active it was. It's showing me, am I keeping my frame rate high? So I can see here that, OK, I'm at about 60 frames per second for a while. That means I'm posting, stuff is happening on the screen. So when I'm navigating in that page, sorry, can you guys see? I can try and zoom in a little bit. So you can see that I have stuff happening on the screen, and then it goes idle when there's nothing else happening on the screen, because probably stuff was done. Or I can see another little spike at the end there. So that's probably telling me, I can infer from that what I saw in the trace. This is telling me that, OK, I had my page navigation, that animation of all the stuff like moving in and out, and then everything goes idle while something is processing before the page is responsive. And then it says, OK, I'm done. Page is done loading. It said done, remember when we just looked at that trace? So that's probably that little spike there, right? So now I sort of know that, OK, this is probably the span of time I care about. And I can verify this by just scrolling down to my CPU usage graph. This is my precise context-switch information that's telling me, again, what is my CPU activity. And you can see that when I highlight this graph, I can see that the highlights move between graphs in this tab so that I can correlate more easily. And I can see here that I have a bunch of CPU activity that finishes right around that spike. And that's probably when my page navigation was done. And so I can go ahead and zoom in right there. And again, I'm trimming my data. I'm zooming my view to just what I care about. I'm digging in. Right? Now, here I can look at the CPU usage graph to figure out, OK, what's going on? What are the active processes that are using my CPU? Is CPU my blocked resource? These are the questions I'm asking. And so here I can see that WWA host is my container for my HTML app. That is what is using the most CPU. I see DWM, that's my compositor. That's using some CPU too, but that's fine, that's expected. And so I'm fairly certain that there's nothing else happening in the system besides my app. And so I can go ahead and filter. And I do this by selecting in the legend or the table, right-clicking, and I say filter to selection. And now you can see I've again trimmed my view. Now this trimming of the view is specific to just this graph. And I can see that my CPU usage for my app, I can see it right here. Now I want to look at the CPU usage for my UI thread. Does everyone know what a UI thread is? Yeah? Yeah? OK, cool. So your UI thread is what's doing, executing your app code, doing stuff on to post updates to your screen, right? Getting your content to the screen. So I've set up this graph to break down my process into different threads that we know about. And we know about the HTML UI thread. Similarly, we know about the XAML UI thread and the XAML render thread. And there are a bunch of other threads that we don't really know exactly what they are, and so we just group them together. And that's that empty line there. But I can enable just this HTML UI thread. And I can see that, OK, my UI thread is pretty much pegged most of the time. It's doing a bunch of stuff. I'm not sure what. I want to know what my UI thread is doing so I can figure out why I'm taking so long with this page navigation, right? And I can see also that there's a little gap here. This might be interesting to investigate, because whenever you have this fast scenario where you're trying to get from A to B in the smallest amount of time possible, if your UI thread isn't using all the CPU it has available, that's probably a problem. And you want to investigate that. Now, for today, I'm going to start with the big chunk of time that is spending, and I'm not sure why. But in the real world, you'd want to investigate both of those things, right? Now, I'm going to investigate just this big chunk of time when it seems like we should be done, and I want to know why that is. And to do that, I'm going to use this other really, really cool graph. And so this graph is the CPU usage attributed graph. Now, what this does is that this already filters down to the HTML UI thread. And then this is showing me the different activities in the framework that my UI thread is doing to get my content to the screen. So are you guys familiar with the idea of a display pipeline of like your app is leveraging the framework to do some stuff for it so that it can put stuff on the screen? That's why you have a UI framework. That's why you depend on XAML or HTML, right? Is so that you don't have to figure out how to lay things out yourself entirely and post these different things. And so you can see here exactly some of that activity. And let me expand this legend a moment so you can see all of it out. And you can see, I see script. I see that's actually the biggest user right now. And we're going to dig into that in a moment. You can see layout. You can see display. You can see formatting. And so if you went to Tobin's talk where he talked about that little arrow and it's going through the different portions of rendering a web page or an app where you're grabbing stuff from the network, but then you have your tree, your element tree, and you're doing layout and formatting to get all your stuff ready, and then you paint. You can see all that stuff in this graph. You can see all the stuff your UI thread is doing in the framework and figure out where you're spending time. And this can be really instrumental in understanding why your app might be taking too long in a given scenario. Now, with this, I'm able to identify that the biggest amount of CPU is being used for script. All right, why is that happening? I want to know why I'm spending so much time in script. And now to do that, I want to start looking at stacks. And so this takes me to the next graph here, or it's actually in just table-only view. And I can see sampled CPU information that breaks down my process into my actual stack. So I'm going to, again, filter. I'm going to filter the selection to my WWA host. I'm going to expand. I care about just the UI thread. I'm going to do that again. I'm going to filter the selection. And now I want to start looking at stacks. Ignore the stack tag column for a moment. I'll get to that in just a moment. And when I look here, I see a bunch of question marks. Now, if you guys haven't seen this before, this is telling me I need to load symbols. I need symbols in order to resolve my stacks so that I can dig into it. So how do you do that in WPA? You go to Trace, Configure Symbol Paths. Now, when you configure symbol paths, I already have this pointing to the public Microsoft symbol server. If you have your own symbols that you want to resolve, you can point WPA to it right here. And the Symcache path is where once we've transcoded symbols, we transcode them into this format that's super fast to load. And so if you have any trouble with any of this, just try clicking on that Help on Symbol Paths link, and hopefully that can help resolve your problems. Now, I've already cached my, my symbols. So this is going to load very quickly, and you can see the progress bar loaded and just dismissed because it's done already. And now I can start digging into this table. Now, a quick note, you don't have to wait for the progress bar to fully finish before you can start digging into your stacks. Just try it, and you'll probably have loaded the symbols you need to dig into the stack. So just go ahead and try it out. And when you need to, you can step back. Now, here I've broken down my stacks and grouped them by stack tag. Now, stack tag is another way of attributing your CPU usage. So you saw in the graph just above with the attributed CPU usage that I'm seeing script, I'm seeing UI thread, I'm seeing display, re-render. We're getting that attribution by using events. We look for event pairs that tell us, OK, in the time between these two events, we know the UI thread is doing script. In the time between these two events, we know the UI thread is doing formatting or layout, right? Stack tags are a little bit different. I want to show you another way of attributing your information. Stack tags are looking at your stack frames. It's saying if I see this module and function, OK, I know that stack is doing script. It's saying if I see this other module and function, OK, I know that's doing layout. Right? So it's another way of attributing. It can be really useful to break down your stacks using stack tags, or you can use the thread activity tags, which are the event-based ones that we used in the previous table. So now what I want to do is I want to dig into stacks. So I've broken them down into different groups. And what I want to do is I want to dig into the most expensive ones first. So you can see in this right, can you guys see? I see 768, 757 for OM and script. So I probably want to dig into both of those stacks and figure out why I'm spending time there and see if I see anything interesting to me, the app developer, right? Now, you want to look at both of them, but for today, let's pretend I've already looked at OM, and I'm going to jump ahead to script. Now, script contains the GC category. Not really interested in that. You can see that That's basically 2.93 compared to 754. I want to spend my time looking at the heavyweight activity here. And now I'm just going to expand and drill down into the stack. And I'm doing this by just pressing right on my keyboard. And what I'm looking for is I'm looking for things that look familiar to me. And so I see some script. I see just like stuff at the top that's just for starting threads. I see MS-HTML. I see on vsync method call. So maybe I have some type of wait happening. I see a loop. And I see, oh, that's interesting here. So can you guys see MS-Apex? MS-Apex is telling me that this is the app, right? So it's telling me my app has, and it says the WPA demo HTML app. It's telling me in the pages, I have a CPU issue page. That's the page I navigated to. On the CPU issue.js page, I have a setup page function, and there's a loop in there. And if I look a few lines above, if you can see, let me highlight that for you. I see MS-Apex, WPA demo HTML app, CPU issue.js, setup page, line 32, column 5. This is telling me, OK, I'm spending, look at the number to the right there, 737 milliseconds. Or is that, wait? Yeah, milliseconds in something related to that page. Now, by drilling down with WPA, figuring out where you want to dig into, zooming in, filtering, figuring out you're spending a lot of time in script, and then digging into your stacks, you've identified a page that seems interesting. So let's go to that page. And we can see here, CPU issue.js, of a function setup page. And hey, I have a loop where I'm waiting for 1,500 milliseconds. That's right about exactly what we saw. Now, this is, granted, a relatively trivial example. You're probably not putting while loops in your code, waiting for a bunch of time. But this can be a great way where you can figure out where you're spending time in your app and dig in and figure out, OK, now I know where I need to focus my efforts in resolving these problems. Now, we'll look at a little more complicated issue in just a moment, where we look at a panning issue and that photo filter app we just looked at. But is everyone with me? You guys good? Anyone have any questions? I can take a quick question or two. You all set? All right, cool. Great. So let's move on and analyze that panning issue we looked at on the phone with Dan's app, the photo filter app, where, just to refresh our memory of that, what we had was a list of pictures that we were panning through, and our pan wasn't keeping up. Our app wasn't keeping up with our pan. Our content wasn't there. We saw through to the background. And that's a problem. We want to understand why that was taking so long. So what I've done here is I've loaded that trace in WPA. I've applied the XAML app analysis profile. I've created a new tab that has a couple extra things, or not extra things, that has gathered the graphs from the different tabs that I want to use to analyze this problem today. And I'm going to use that same process we just used to figure out what's going on. So the first step, again, locate the scenario within the app. Now, I don't have window in focus or touch events on this trace. However, I do have frame rate and something very interesting that I'll get to in a moment. Now, again, we can use frame rate to identify sort of where I'm interested in the trace. And you can see, just look at DWM frame rate and CPU usage. OK, this is where the bulk of the activity was happening in the trace, right? We can see it in just the graph in a graphical form, where I see 3 spikes of DWM, where it looks like it's keeping up at 60 frames per second for a little bit. It runs out of content, so it has nothing left to show on the screen. So it drops to idle. It gets some content again. It spikes back up to 60 frames per second, runs out of content again, because I did that a couple of times. And then finally, I stop panning. I give up on the app. And then it finally catches up on the content, and it's all there and full, right? So OK, that's what I want to focus on. So now I'm going to go ahead and, whoops, I need to get out of the zoom. I'm going to zoom in to just that time span. Now, I have another cool thing I can use to figure out where in the trace I want to look, and also give me a lot of insight into the app. And that's custom instrumentation. So if you guys are using the app logging events or the app logging APIs, this shows up whether you're on phone, whether you're on a Windows tablet or a PC, whether you're on HTML, whether you're on XAML, whatever it is, you have app logging APIs. Use them, and you can figure out, you can get yourself a lot of help and figure out where in the trace you want to look, and also giving yourself some insight into what activities you're doing. And so if I look here at this events that Dan has in his photo filter app, I can go ahead and expand that out. And I can see that I'm spending, looks like I have a bunch of events firing with the string, fetching pictures from disk. OK. We know the scenario we captured a trace for. We saw that we were scrolling through a list of images. OK, it makes sense that I'm fetching pictures from disk. And so this is giving me some insight into where in the trace I want to focus, but it's also giving me some interesting information. Look at the pattern here. I'm seeing them all these events clustered in pairs of 2. That's a little bit weird. Why aren't they evenly spaced? Right. OK, I can get that there's different clumps of them based on when I panned, but why are they all sort of in pairs of 2? So keep that sort of odd, interesting fact in your mind as you dig in further. And the next place to look is really, once again, your CPU graph. And so this is, again, CPU usage precise. And I can look here to see what are, and what I want to do is identify my bottleneck, right? Am I blocked on CPU, disk, GPU? And I can see that it looks like, again, I'm blocked on CPU. There's a bunch of CPU activity happening. And if I look at GPU, there's not very much GPU activity, right? Look at GPU. I see mobile-ui.exe. Again, that's our compositor on phone instead of DWM. There's not much GPU work there. There's really mostly CPU work, right? So I already know, OK, I want to focus on CPU. And I'm seeing something interesting here, where normally what I see is my app, photofilter.exe, or www host for your HTML container. That's what's normally using a bunch of my CPU resource, right? But this time I'm seeing runtimebroker.exe. What is that? What's going on there? This is telling me that the most heavy user of CPU in this time is runtimebroker.exe. Now, I know my app. I know Dan's app. And I know that what we're doing is we're getting images from the disk, just like our instrumentation told us. It makes sense and lines up with what we saw when we captured the trace. And now I'm seeing that, OK, runtimebroker.exe. That means I'm getting the images async. I'm not waiting on my UI thread to do that. And so runtimebroker.exe is grabbing the images, but it has a bunch of work to do to get those images ready. So now, again, I know there's something to do with the image load that's taking up a bunch of time in this scenario that I want to dig into and understand why that's happening. And so I can go ahead and make this a little clearer for us by just selecting the top 3, filtering down, and I can see, get rid of those other spikes that aren't taking up that much time. I could look at just the CPU usage for photo filter, and I can see it's really spiky. It's not pegging its UI thread fully, so there's something weird happening. I can see that runtime broker is there and mobile UI.exe is there. But really, there's something odd happening in my image loading. So already I have some information that I can use to go back to my app and make some changes to make things better, right? But I want to dig in further. I want to see how else I can figure this out. So to do this, I'm again going to go to the attributed graphs. Now, the attributed graphs are, again, this is for XAML now. So I see 2. There's 2 attributed graphs that are interesting for us. There's a XAML UI thread and the XAML render thread. But I can see that, OK, and I can see a bunch of interesting work happening. I can see XAML render stuff that I'm not as familiar with primitive walks and update viewports. And you can dig into that. But for the UI thread, you can see the measure. That's the equivalent of layout. You can see UI thread work. That's the equivalent of script on HTML. But the biggest user of activity here is apply template. Now, apply template taking this much time of my UI thread, OK, that's interesting. It's not necessarily bad, but it is interesting. So now I know that I want to look at image loading and apply template. And so now in my app, OK, I know I have to bind a photo to my template and apply it for each item as I'm scrolling through my list of photos, right? OK, so now I know, based on the attributed graph, my custom instrumentation, and my CPU usage information of where in the code I might look to find my performance problem. But let's keep going. There's some more ways you can find this out. So to do this, I'm going to look at two new graphs that we haven't looked at yet. The vsync graph and the XAML frame graph. Now, vsyncs, if you're familiar, are you guys familiar with vsyncs? Ish? Some? OK, let me explain vsyncs very quickly. So vsyncs are saying, and actually I'll zoom in so you can see this a little clearer. Now, vsyncs, you can see, you have this time span, which is about 16 milliseconds. And a vsync is basically the hardware saying, OK, my screen, I'm ready to update my screen. Give me what content you got, and I'll put it up on the screen. Right? Now, so a vsync is occurring every 16 milliseconds. And a vsync is super helpful if you want to analyze dropped frames, glitches, frame rate issues. You want to be looking at vsyncs to figure out, OK, when am I missing these vsyncs? And you can look one line below at the schedule frame updates. And that's saying, OK, yes, I see there's a vsync. I've presented a frame to put on the screen. Now, if we look elsewhere, and this correlates with the frame rate, right? If I look back up here, frame rate is all the way up here. So it's 60 frames per second. That's saying that, OK, yeah, I'm scheduling updates for every vsync. If I go into a different portion of the trace when the screen is idle, then there's nothing happening for me to present. That means that's interesting. In my panning scenario, I want to make sure that all the content is there for updates to be presented to the screen always, every 16 milliseconds, so we can keep up, be smooth. Right? So for frame rate drops, for glitches, the vsync graph is super interesting to look at. Now, once you use the vsync graph in conjunction with other graphs, using it in conjunction with CPU and GPU, and you can also use it in conjunction with the XAML frames graph or table. And the XAML frames table, and I'll expand this a little bit. And there is an HTML frames table. It works the exact same way. And so what I've done here is I have the XAML frames table that is for my app. I see photofilter.exe. If you're looking at an HTML app, you would see www.host.exe. And you can dig down through different lines. And I can click and go down through this. And if you can see, there's a couple things that might be interesting for you. So let me get this in view. And so I can see that as I'm going down the different frames, I can see highlighted in my CPU graph, in my attributed graphs, in my vsync graph, how long that frame took. And that time is on the right. I see that time in red, the task exclusive time. And that's saying, OK, I had some framework frames, some UI frames that were taking 80-something milliseconds, 40-something milliseconds, 400-something milliseconds. And that seems to correlate very heavily with the time when there was nothing to update on the screen, because we didn't have our items ready and rendered to put on the screen. OK, we have an expensive frame we want to dig into. And we can keep going. We can see 581, 89, all these different ones that are interesting to look at. So let's just pick one of them and see what was happening. And actually, let's pick the one that says 900 milliseconds. Right? That's a big span of time when there's nothing to update on the screen. And I want to understand, why did we spend 900 milliseconds, almost a second, waiting to update stuff on the screen? So I can go ahead and dig in, expand it just like a stack. I'll scroll to the right a little bit. And I can see measure. OK, I'm spending a bunch of this time measuring in like the measure process. Right? Not process as a process, but like measure activity. So I can keep digging in. OK, I'm measuring different elements and items, list boxes. And I keep just digging in to look to see, OK, where am I spending all this time? And I can see that looks like a lot of this time is spent in apply template, which is exactly what we saw when we looked at the attributed graph. But this is telling me specifically for this 900 millisecond span of time that I'm spending most of it applying templates for 11 items. And you can see that by seeing the count or just counting down here. OK, 1 apply template, 2 apply template, 3 apply template. and so on. And I can see that that's 11 apply templates that was happening in this frame that caused it to be so expensive. And that's happening because if I count on the screen of my phone, I can fit about 6 items on the screen. So I'm trying to render out about 2 screens worth of stuff out in this frame. And that's part of why it's so expensive. But also, these apply templates seem to be taking a significant amount of time. So by using the frames graph, the attributed graph, the CPU usage graph, and my instrumentation, I'm again figuring out I want to look at my templates, my image fetching, and dig into that. So let's go back to our code and check that out. So I'm in just main page.xaml, and I want to look at the data template. Now, here I seem to have a relatively normal data template, but I'll draw your attention to this, where I have my image twice. It's the same image, just happening twice. And because of that, I have a much more expensive apply template cost, and that's causing my panning to just be abysmal. And so this is a great way where you can figure out, OK, I figured out where in the code I want to look for the error, the mistake, the too complicated of a data template or what it might be. I'm using tracing and WPA to do so. And I'm also using instrumentation. I want to show you very quickly, if I go to this image item class, I have this one line here that's instrumentation.log message. And I'm logging that string, which is exactly what we saw in WPA. You have to initialize this in some ways, and we can link you to some information to exactly how to do that. But I highly recommend you instrument your app as well. It's going to be very helpful in investing in your trace. So that's really the talk. And we have a bunch of resources that I want to show you. So if you guys have questions, you can start lining up or just be ready to shout them out. But let me show you some resources real quick. So the resources are, first, the Windows Performance Toolkit. Now, as I mentioned, you are going to see a slightly older version from this past August of the RTM bits of the WPT. And so you can download that by just going to this here. And if you have feedback, go to the forum, go to Help Windows Performance Toolkit forum. Oh. I'm pressing all the buttons I can think of. I'll just talk to it. You'll see the links in a second. And in addition to that, we also have a bunch of short videos that will get you the links for. And what I recommend, I have a bunch of stuff in this deck. So go to Channel 9, find this talk, and download the deck. And I'll show you exactly why you want to do that. No, if we can get that back up. I'm not sure what I did. I might have pressed that one by accident. Sorry about that. While that's getting sorted out, I have a couple of short videos that we've put together on the Performance Toolkit team that are going to help introduce you to WPA and also show you how to use the profile, the XAML app analysis and HTML app analysis profiles, and show you a bunch of cool, interesting graphs there. Then we can also link you to talks from last year. There's the mental model talk I did last year that can give you context into those vsyncs, into the UI thread, the compositor, all of that information. There's a Windows Performance Toolkit talk that gives you all the different features in WPA that Shel Sterioff did. There's platform fundamentals for web that Tobin did last year and this year. And then there's XAML, again, from last year and this year. And all those links are in the deck, and I'll get them to you. But what's super useful is a bunch of resources that give you a list of useful WPA graphs. Oh, actually, maybe I can just bring it up in. OK. Sorry about that, guys. 1 second. Yeah, sorry about that. And what's really useful is a bunch of useful graphs that show you a bunch of useful graphs, but also problems. And so you can see that this slide shows exactly that problem we looked at just earlier in the first demo, where I'm seeing unnecessary code execution with a bunch of JScript OOM activity in the attributed graph. And similarly for XAML, you would see XAML UI thread. And if you go, you can see expensive format work looks like that, where you're looking for Trident format. That's for HTML. For expensive layout, you're looking for Trident layout, or XAML UI frame layout, or range. And all these different ways to identify lots of cool problems using WPA. And a lot of thanks go out to the guys who put together these slides, particularly Will back in Redmond. And so I've just compiled them in this deck. So please check out the deck, if nothing else. Go to Channel 9, download the deck, and you can use that as a resource to figure out how to interpret some of the cool things you're going to see in WPA. So with that, I'm pretty much done. If you guys have feedback, please do fill out your survey and tell us what we can do better. And if you have any questions, I'm happy to take them now.
Yeah, can you elaborate how to use this a bit more popular app?
Sorry, I can't quite hear you.
Can you highlight how to use it with more popular apps, like standard Windows application?
How can I use the Windows Performance Toolkit with desktop applications or other apps, right? And the same concepts of analysis apply, where you want to identify where in the trace you want to look. Now, what you won't get is you won't get the attributed information, because we don't have any attribution for whatever UI frameworks that might be on the desktop right now. So what you would want to do is use frame rate information and CPU information to figure out where you want to look. And you can, again, dig into stacks. That's probably your best bet, is to dig into stacks for your desktop apps. Any other questions? The Visual Studio Profilers, if you're talking about the stuff with like the UI responsiveness tools, is that what you're referring to? It is not. What I'm most familiar with is WPR and the developer power tools, and that's typically what we recommend. But you can follow with me offline, and we can figure out exactly what you're referring to. No, I recall, but I'm not sure why it's with VS. So yeah, we can figure that out.
Why should I use this tool versus the built-in Visual Studio, which shows me power consumption, memory, and all of that?
The differences between the Windows Performance Toolkit and the Visual Studio Profiler tools is that really you should probably start in VS, and that gives you a lot of different insights. WPA gives you a lot of powerful ways to manipulate your data and visualize it, so you can figure out what's going on. So if you really have a performance problem that you're still having despite your best efforts, go take a trace and look at it with WPA. And it has a bunch of features that can help you pivot your data and figure out what's going on. So that's really the progression we'd recommend.
I've got two questions.
Go for it.
Is there any plans to incorporate bandwidth into some of the graphs, or is that rolled into usage?
Let's see. We do have the WinINet graph, and I'm not as familiar with that graph, and that shows you like how long a network transfer took.
Oh, sorry, I mean like CPU or main memory bandwidth or GPU bandwidth.
Oh, memory bandwidth. That's something we'd like to do in the future, and it's not something that's as fleshed out at the moment for memory.
And then another question, with power variability and CPU frequency variability and everything, has your team worked on how to incorporate that into the graphs?
We don't have a great visualization for that right now. I recall a blog post by, the name is escaping me, I think it was Bruce, and I'll try and find it, that was saying how he could diagnose this with WPA with the current tools, but I don't recall it right now. So if you can find me offline, I can try and find that and send that your way.
Sure.
Cool, thank you.
Related question, is there any plans to add network captures to the tool?
Network captures, I'd refer you to the WinINet graph, and if you take a trace now, I think it's lit up, and you can just drag that graph forward and look. In the slides, there is a slide or two that's referring to that WinINet graph, and you can see how to use that there.
Thank you.
Yep.
Is it possible to analyze device drivers and more internals, not applications, with this tool?
It is, yeah. We actually use it heavily internally. The kernel team uses it, a bunch of drivers, partners use it. So this is definitely the performance tool for all your performance problems in a lot of ways. What you won't get is that type of attributed view that I was showing you into the frameworks because you don't care about those frameworks. So, but you can still use,
all the stack and,
you can still, yeah, assuming you have the right providers enabled, if it's in the trace, we can show you call stacks and you can dig into them. Yep.
Hi, my question is, can we use WPT during performance test, or is this something that's used after a performance test is done?
Can you define performance test?
Just running multiple concurrent users using Visual Studio load test tool or
Okay.
different tools like Load Runner or...
Yeah, so what so the WPT, you would use Windows Performance Recorder to capture your trace. If you want to capture a trace using some other means, that's certainly fine as well. In terms of like stress tests, if that's a scenario you're concerned with investigating, then yeah, sure. It's the same as when I run through panning because I want to investigate that scenario. In your case, it would be I want to run through my stress test and capture, trace, and investigate why we can't keep up when we're trying to scale up. So it's the same basic concept of you want to start tracing, run through your scenario, whether that be page navigation is slow or I have multiple concurrent users and things are slow for each of my users. Save the trace and then open it in WPA and check it out. Yeah.
Maybe you answered this already, but could you clarify, does this work for standard desktop WPF apps, or is it just a new 8 point something?
You can definitely capture traces of any app and look at it in WPA. What you won't get when you're looking at desktop apps is that attributed view, where what we've attributed right now is that converged platform of XAML and HTML for Windows and Windows Phone. And so that attribution will show up. But if you're using any other UI framework, you won't get that attribution yet. But thank you for the feedback.
Any plans to get it?
No plans at the moment, but thank you for the feedback, and we'll see soon.
In the native app, there are a lot of message interactions. Would there be any obvious patterns in your tools that would show the message blocking?
I haven't done that myself, but I know it's possible. And so what I probably look at is if you open up the profile I mentioned, you can see the third tab is like the thread delays tab, and it shows you CPU information and a graph that might be useful for you there. And so I'd refer you there, and if you have more trouble with it, follow me, and I'll see if I can find the right answer for you.
Sure. I mean, the stack would obviously show things, but
Right.
Other than that.
Yeah, I don't have a better answer for you right now, but if you follow with me offline, we can see if we can find a better one.
Thank
Cool,
you.
thank you.
Is there any way for HTML5 apps to investigate XHR requests?
I'm going to refer that question to Tobin. The answer is yes, and if you follow with him offline, yeah, he'll give you all the details. Yeah.
The Visual Studio Profiler captures the performance counters, the CPU counters. Are there any plans to incorporate that in the ETW traces as well?
There aren't any plans at the moment. You should follow with me offline. I'd love to hear what you'd use that information for.
Because I want to see them in the context of application traces as well.
Okay. Yeah, that's good feedback. I don't think that's possible right now, but let's chat after.
You do that on the Visual Studio Profiler.
Yeah.
You do that with the ETW traces too.
Yeah. Yeah, sorry, I don't have a better answer for it now. Oh, yeah, the question was, can we get performance counter information in ETW traces? And I don't think that's possible right now, but that's something we can look into. Yeah, thank you.
Hi, will this technology work for analyzing performance of apps that are running in a web browser, either IE or Chrome?
Absolutely, yeah. And just use the HTML application analysis recording profile I showed to capture the app on that surface right there, and you're going to get all of it. And that's actually what we do internally. And if you saw Tobin's talk last year, he's using WPR to capture traces of a website, and then using WPA to look at it. So it's pretty cool. It works.
Okay,
Yeah.
great. Yeah, so it'll work well with single-page applications.
Yeah, absolutely. And you're going to get that same attributed view because you're using IE is the same browser same engine that powers our HTML apps.
Okay,
So you're going to see all that cool stuff.
That's what I
Yeah.
thought. Just wanted
Yeah,
to confirm.
for sure.
Thanks.
All right, any more questions? Cool. Oh, one more.
Is it backward compatible for desktops that I can run it on Windows 8, for example, and do performance there with the latest version?
As in, can I run the Windows Performance Toolkit on previous versions of Windows? The answer is yes. Yeah. Cool. Thank you, guys. If you have any more questions, I'll be here.